Now let us see the implementation of stack using arrays in C language. These are standard header files in C. This line includes the standard input-output library in the program. This library provides the functions like printf and scanf for the input-output operations. This line includes the standard library in the program. This library provides the functions for dynamic memory allocation, process control functions, and other utility functions such as malloc, free, and exit. In this particular program, exit function from the stdlib.h is used to terminate the program with a specified exit status. This structure represents the stack. It contains an array of items to store the elements of the stack and an integer top to keep track of the top element of the stack. This keyword type def in C is used to create an alias or synonym for the another data type. It allows us to define the custom data type using existing ones. This defines an unnamed structure in C. Structures are used to group of different types of data under a single name. Here inside the structure there is an array named items of type int with maximum size of max size. This array represents the storage space for the elements of the stack. This is an integer variable named top which represents the index of the top element in the stack. This concludes the definition of the structure. The stack name is provided here using the typedef keyword, which makes stack an alias for this structure. Now stack can be used to declare variables of the structure type without using the struct keyword. For example, stack mystack declares a variable mystack of type stack. Function to initialize the stack. Here, this line defines a function named initialize that takes a pointer to a stack structure as an argument. The function doesn't return any value. Inside the function, it assigns the value -1 to the top attribute of the stack structure that stack points to. This operator is used to access the top attribute of the stack structure through the pointer stack. In summary, this function sets up the initial state of the stack by marking it as empty with top set to -1. Function to check if the stack is empty. This line defines a function named isEmpty that takes a pointer to a stack structure as an argument and returns an integer. Here inside the function it checks the top attribute of the stack structure that stack points to is equal to -1. If the top is -1, it means the stack is empty. The comparison stack top is equal to -1 returns either 1, that is true, if the stack is empty, or 0, false, if it's not. In summary, we can say that this function returns 1 if the stack is empty and 0 if it is not. Function to check if the stack is full. This line defines a function named isFull that takes a pointer to a stack structure as an argument and returns an integer. Here inside the function it checks the top attribute of the stack structure that stack points to equal to max size -1. If the top is equal to max size -1, it means the stack is full. The comparison stack top is equal to max size -1 returns either 1, that is true, if the stack is full, or 0, that is false, if it is not. Function to push an element onto the stack. This line defines a function named push that takes a pointer to a stack structure and an integer value as an argument, and the function doesn't return any value. This line checks if the stack is full using isFull function. If the stack is full, it prints stack overflow and returns from the function indicating that the push operation cannot be performed. If the stack is not full, this line increments the top attribute of the stack structure pointed by the stack. This step prepares the stack to accommodate the new element. Then it assigns the value to the array element at the index indicating by the updated top attribute. This effectively adds the new element to the top of the stack. In summary, this function pushes a new element onto the stack if there is a space available. Otherwise, it prints the stack overflow and does nothing. Function to pop an element from the stack. This line defines a function named pop that takes a pointer to a stack structure as an argument and returns an integer. This line checks if the stack is empty using isEmpty function. If the stack is empty, it prints stack underflow, indicating that there are no elements to pop, and then exits the program with the error code of 1 using exit 1. If the stack is not empty, this line retrieves the element at the top of the stack, and this assigns it to the variable popped item. After retrieving the element, it decrements the top attribute of the stack structure pointed by the stack. This effectively removes the top element from the stack. Finally, it returns the popped element. In summary, this function pops the top element from the stack if it's not empty. If the stack is empty, it prints the stack underflow and exits the program. Function to peek at the top of the element of the stack. This line defines a function named peek that takes a pointer to a stack structure as an argument and returns an integer which is the value of the top element of the stack. This line checks if the stack is empty using isEmpty function. If the stack is empty, it prints stack is empty, indicating that there are no elements to peek, and then exits the program with an error code of 1 using exit 1. If the stack is not empty, this line returns the element at the top of the stack. It doesn't modify the stack in any way, just retrieves the value. In summary, this function peeks at the top of the element of the stack if it is not empty. If the stack is empty, it prints the stack is empty and exits the program. Now we will see the main function. This line declares a variable stack of type stack which represents the stack data structure. This line initializes the stack by calling the initialize function and passing a parameter to a stack variable. Push elements onto the stack. These lines push elements onto the stack using the push function. In this case, the elements 10, 20 and 30 are pushed onto the stack. Peek the top element. This line peeks at the top element of the stack using the peek function and prints its value using printf. Pop elements from the stack. These lines pop elements from the stack using the pop function and print their values using printf. Trying to pop from an empty stack. Uncommenting this line will cause stack underflow. This commented outline demonstrates an attempt to pop from an empty stack. Uncommenting it would indeed cause a stack underflow, which is why it's left commented. Return 0. This line indicates that the main function has completed successfully and the program should exit with a return code of 0. This return code conventionally indicating success in most operating systems.
Like, comment, and subscribe.